Hi guys, I hope you can see me. Had a lot of questions about this Brainbusters 1, and I figured it would be good if I recorded maybe a short little video tutorial about what all this alpha level, beta error, rejecting, accepting the null, all of that stuff. I recognize that there are some of you that have not had statistics, and so the terminology and everything is crazy confusing. So I'm going to try to break it down real simple for you in maybe 5 or 10 minutes, hopefully give you what you need to better understand Brainbusters 1. As always, if you have any questions or if this didn't answer your question, please don't hesitate to give me a call, send me an email, and we'll work it out. So I don't like recording myself, so I'm going to kind of move the camera onto the different tools and things that you can use to work through this assignment. So here we go. First of all, and I'm sorry that this is going to be kind of herky-gurky, but deal with it. A lot of people have asked, hey, what's all this with the alpha? How do I find that? If you go into the course, let me show you real quick how to find it. So if you go into the course on the home page, looks like these for you. Learning units, Unit 1, Neuromaterial, assignments and exams. Here you've got an alpha level table. So if you pull that up, you get something that looks like this. It's a little bit old. It looks like someone made it on a typewriter in 1948. I went online and I searched for critical t-value chart, and I came up with something like this, which I think is a little bit easier to read. I'll go ahead and use the one that we've got online so that we can all be on the same page. So essentially, we're talking alpha level here. So we have 0.1, we have 0.05, we have 0.025, 0.01, etc. And basically, these are the values that Gary refers to as p-values. In true statistics, there's a difference there, but we'll go ahead and keep with the terminology that Gary uses because I think it'll simplify things. So when Gary says p equals 0.05, he's talking about this alpha level of 0.05. If we convert that to a percent, so we say, okay, p equals 0.05, that's actually 5%. And what we're saying here with an alpha level is we're saying any differences that we see between two groups of numbers or two groups of means or whatever it is, we're going to let random differences account for 5% of the total differences. But if we have more differences than just 5%, or that the differences are greater than 5% different, now we're starting to think, hey, it was something other than just random events. Meaning, okay, so I'm comparing two instruments. I'm going to run 100 tests for potassium on one instrument, 100 tests for potassium on the other instrument. I know I'm going to have differences between the two. There's no way in the world that 100 tests on one and 100 tests on the other are going to be identical. So the question in statistics then is, what are those differences? Are they really significant, or was it just some sort of random occurrence? Maybe a pipetting issue, maybe the reagent that was on the machine was a little bit different or had a bubble, who knows what. So what we're doing by setting this alpha level at 0.05 or 0.001 is we're going to say, okay, let's ignore up to 5% of random occurrences here. We want to look at any difference that's greater than that. So that's where we start talking about something being, oops, sorry, you're all getting nauseous. That's where we start to say, okay, the differences I'm seeing here are actually significant. Meaning, random chance didn't cause it. There is a difference between the two instruments here.